Hello, I'm Cheorun Jo, Department of Agricultural Biotechnology, Seoul National University, South Korea. Today, we are going to share the knowledge about food irradiation and its application. Let's talk about the background first. The keywords for 21st century for improvement of quality of life are food, energy, and environment. Somebody also say water too. Well, I guess everybody agree this. This is a famous picture. In 50 years, the world population will require 100% more food, and 70% of this food must come from efficiency, improving technology. Right now, we produce more food than at any time in history. However, there are a lot of limitations to increase our production amount of food more. In these circumstances, we need indirect increase of food producers instead of direct increases such as genetic modification and others. The most efficient way to increase food indirectly is to reduce waste. Over half of the food produced globally is lost, wasted, or discarded as a result of inefficient human-managed food chain. Also, foodborne disease is most widespread health problem in the world and an important cause of reduced economic productivity. In food safety point of view, chemical residues, allergens are also considered as very important. Then now, what do? We need to increase productivity of the food, reduce post-harvest loss, and extend the shelf life and ensure food safety. Let's see the brief video made by International Atomic Energy Agency, IAEA, about food irradiation and its concept. Please watch the video.
Electromagnetic radiation covers a broad spectrum of wavelengths and includes sunlight, which is vital to life on Earth. The waves have different uses according to their energy. Radio waves enable us to communicate and share information. Microwaves cook our food. Infrared radiation warms us. Visible light illuminates our lives and is essential for food production. Ultraviolet radiation gives us suntans and bone-strengthening vitamin D. X-rays enable us to diagnose and treat illnesses and to check our luggage. And gamma rays are used to sterilize medical equipment. Irradiation using X-rays and gamma rays can also be used to treat food. By choosing the right wavelength and dosage, these rays can prevent sprouting of vegetables like potatoes, maintain their freshness and taste, and destroy harmful bacteria that could be present in spices, meat, or seafood. They also can rid fresh fruits and vegetables of insects that might otherwise hitchhike, spreading to other regions of the world where they could have devastating effects on the environment and agriculture. Food irradiation involves shining electromagnetic rays or beams of electrons onto food. The energy is transferred at an intensity necessary to give the desired effect. It is a cold process, so spices retain their unique flavors and aromas that would be diminished by heating. It also avoids reliance on chemical methods, such as fumigation or pesticides, to combat bacteria, insects, or other spoilage organisms. In addition, those irradiation beams pass through packaging, so the food remains protected from bacteria or insects after treatment and will remain fresh longer. Food irradiation offers a chemical-free and heat-free approach. It maintains fresh food quality, reduces the risk of foodborne diseases, and prevents the spread of exotic insects through globalized trade.
Okay, this is very good summarization of food irradiation. So food irradiation can be defined as a process by which food is exposed to a controlled source of ionizing radiation to prolong shelf life and reduce food losses, improve microbiological safety, and or reduce the use of chemical fumigants and additives. Food irradiation also can be used to reduce insect infestation of different grains and dry spices and others, inhibit sproutings and tubers and bulbs, retard post-harvest ripening of fruits, inactivate parasites in meat and fish, eliminate spoilage microbes from fresh fruits and vegetables, extend shelf life in poultry, meat, fish, and shellfish, and then sterilize foods and feeds. So we can summarize that the purpose of using food irradiation is food security, food safety, and food processing, then international trade, quarantine process. So let's talk about the food irradiation sources. WHO and other institutes allowed the irradiation sources that can be used for irradiation of food or public health related products. We have three different radiation sources: gamma ray, electron beam, and X-ray. The radiation source of gamma ray are cobalt-60 and cesium-137. They are radioisotopes with half-life of 5.3 years or 30 years, respectively. Electron beam and X-ray uses a linear accelerator, but energy level should be less than 10 million electron volt for electron beam and 5 million electron volt for X-ray. Electron beam uses electron which have mass and transfer as a particle. Therefore, they have direction from here to here, and the beam can be stopped by turning up the electricity. Gamma ray, on the other hand, uses radioisotope by turning, which radiate energy 360 degrees all directions without stop. X-ray is generated by the collision of electron beam to a metal target, and this metal produces photons like gamma ray. So these are electromagnetic waves as of photons, and the penetrating depth of gamma and X-ray, which transfer the energy as a photon without mass, is much, much higher than electron beam. Food radiation process is very simple. We put fully packaged food in front of irradiation sources, and the food is irradiated. During irradiation, pathogenic bacteria contaminated on foods may be killed. We use this observed dose as irradiation dose or level, and use gray or kilogray for unit of observed dose. 1 gray means a material absorbed 1 joule per kilogram of material by radiation. So this is the typical gamma irradiation facility. The food or other packed on pallet and placed on totes at loading docks. Here, this is a loading dock, and go through the irradiation sources and then go back and unloading here. Cobalt-60 sources is in deep water pool and hoist up when irradiation process begin. Electron beam irradiator looks like gun or beam. Electron beam is continuous system, easy on-off system, and rapid process. However, electron beam has low penetration when compared with gamma irradiation or X-ray. X-ray irradiator is again made by collision of high energy electron with the metal target without using any radioactive materials. They have good penetration capability, similar to gamma ray, and easy on-off system, similar to electron beam. So X-ray has advantages and lose limitations from both gamma and electron beam irradiation. However, the limitation of X-ray facility is very low energy efficiency and still very low. When you see this table, you can find the different characteristics of irradiation sources. If you see the penetration depth of energy, gamma ray and X-ray penetrate much deeper than electron beam. However, the penetration of electron beam irradiation is enough to irradiate the boxed meat on a conveyor. When you have to select the irradiation sources, you should consider treatment goals. Is it for pasteurization or sterilization, insecticide or growth control? Is this food characteristics of target foods like thickness, density, contamination, degree, moisture content, and others. And energy characteristics like penetration capability, energy efficiency, or source control. And the minimum dose and dose uniformity for treated food. And most importantly, economics of the sources. The mode of action of irradiation can be divided into two, which is direct and indirect effect. Direct effect means direct ionization of nucleic acid of pathogenic bacteria, lesions produced in genetic material such as breakage of single or double strand of the DNA during irradiation process. Next, the indirect effect usually come from the water. Cell cytoplasm contains approximately 80% of water. Hydrous radical is a radioactive, radiolytic products of water, and this hydrous radical is very reactive with other cell components. Interaction with this radical, bacterial live cells are damaged and killed. As you saw before, the irradiation process is very simple, one process, but can have multiple uses, including sprout inhibition of onion, potato, ginger, garlic, and insect disinfestation of cereals, pulses, dry fruits, quarantine of fruits in international trade, pathogen reduction of the spices and fresh foods, and shelf life extension of meat and fish. Irradiation technology already in market applied in different medical lines, pet foods, diapers, and others. So we can see in the commercial level. This process also can apply for sterilization of medical devices, cosmetic products like brushes and powders, oriental medicinal or health-related products, and pathogen-free feeds. Already 53 countries allowed to use irradiation process for food, and 250 items are authorized to be used commercially. If the cost of irradiation process is compared, irradiation process is the cheapest process among the different disinfection treatments, like hot water disinfection or steam treatment, or refrigeration, or cold controlled atmosphere process. So yes, indeed, irradiation is very good and easy method to make food safer. Let's summarize the advantage and disadvantage. The advantage of food irradiation process are non-thermal treatment. Food irradiation does not increase temperature of the food. Thus, it is called cold pasteurization. It can be used for packaged and frozen products. In addition, fresh produce like salad vegetables can be treated without chemicals. It is cost-effective and can apply automatically. However, the disadvantage of irradiation process is high initial investment cost because the irradiation facility is a little big and expensive. Low consumer acceptance. This is really a problem. Many consumers must understand the term irradiated food and its safety. and others such as inaccuracy of detection method or of irradiated foods. Sometimes irradiation, which has very big energy, changes food quality. However, this is negligible in commercial level. So I can say food irradiation is a real eco-friendly technology in food preservation. Then, is irradiated food safe? As elderly people ask about this. Well, American Medical Association, World Health Organization, Centers for Disease Control, American Dietetic Association, Institute of Food Technologists, and others. All these institutes and almost all scientific bodies say yes, absolutely, irradiated food is safe. Many people ask, is irradiation of food make nutritional loss of food? Is this process used for excuse of clean up filthy food? Are there any chemical changes exist and flavor changes and other unknown risks? Is irradiation make food more expensive? Let's get into answer one by one. So, irradiation reduce nutrients in food. Let's say all processing of foods, including cooking, canning, freezing, decrease in nutritional content. FDA has determined that nutritional loss from irradiation is insignificant. Irradiation fruit can be shipped riper than non-irradiated fruit, resulting in higher vitamin A and C content. This is the result of nutritional value of frozen ground beef, irradiated or non-irradiated beef. As you can see, there was no difference between non-irradiated and irradiated beef. Encourage unsanitary practice in processing plant. Well, let's say irradiation is an additional food safety step and does not replace proper food handling and cooking practices already in place, like HACCP. Some people criticize that there are no long-term studies on safety of irradiated foods. However, the process of irradiation has been more thoroughly studied than any other food preservation methods. There have been more than 500 scientific papers published on the safety and effectiveness of irradiation during the past 60 years. Here's the pillars of public health: pasteurization, immunization, and chlorination of drinking water was resisted to use by people at first. However, they are now necessary process for our health and public health. Irradiation must be one in the future. This is a quiz from anonymous writers talking about people's fear about new technology. Let's read it. A new technology called thermal radiation has been developed that improves both the texture and taste of some foods. The process also kills many non-pathogens and extends the shelf life of some foods. Unfortunately, thermal radiation, new process, also reduces the vitamin content of some vegetables, produces some benzene in eggs, and causes charcoal-like carcinogen on the surfaces of meat. Therefore, this process, also known as something, has been banned pending further studies. So what would be the answer? The answer is cooking. As you know, as all processes, even we are using everyday life, like cooking, have their own good and bad side. Irradiated food must be labeled with this symbol. We call this symbol radura. When you find this symbol on package, the product means irradiated for safety improvement or shelf life extension. These are the current application on meat products in US market. You can see the radura mark here, and some restaurants or some company uses irradiated irradiated meat products. Along with food safety enhancement, there are novel applications progressed using radiation technology. The trend of irradiation technology change as low dose usage to high dose usage. At the initial stage, 5 kilogram or less dose of irradiation was applied for a stable supply of foods. At 2000, mid-dose range from 3 to 10 kilogram used for cleaner products and safer foods. Later than 2010, high dose higher than 10 kilogram is applied for long-term storage, special foods such as military combat foods, sports foods, or space foods, and foods for elderly or patients. Let me introduce an example of food irradiation for development of special purpose foods. For this, we should consider nutrient requirement, because nutrition should be modified or fortified to meet nutrition requirements of each target groups. And space food should have a shelf life over 2 years at ambient temperature. So we need to long shelf life when we develop the special purpose foods. And microbiological safety. Sterile foods without pathogenic microorganism is necessary. The sensory quality. Appetite is usually decreased by stresses. And special purpose foods are usually consumed in stress conditions. So sensory quality is also very important. And lastly, the special purpose food must be convenient for preparation. Important advantages of irradiation technology for special purpose foods are, firstly, irradiation is cold process. If heat treatment is applied for microbiological safety, it changes the original taste or texture. Secondly, because of deep penetration depth of irradiation energy, it is possible to sterilize the food after final packaging. This eliminates the second contamination possibility after sterilization process. Here is some Korean space food developed at 2006, including kimchi, ramen, bulgogi, bibimbap, and others. Space kimchi was once introduced in Science magazine in 2006. Let me show you one more short video for food irradiation as a special purpose foods.
Throughout history, insects have posed challenges by spreading diseases, by damaging crops, and by affecting environments, causing damage that amounts to more than $70 billion a year. With climate change, insects are now moving into areas where previously they could not survive. This means authorities must implement strict quarantine measures across international boundaries and within countries. Thanks to a treatment that has been used safely for more than 50 years, countries are already in a position to deal with this threat. The treatment is food irradiation. Initially used to ensure safety of high-value spices, fish and meat, food irradiation treatments are increasingly being used on fresh fruits and vegetables to prevent the spread of invasive insects. Higher temperatures and humidity of climate change also aid the growth of organisms such as bacteria or molds that can cause food spoilage or food-based illnesses, putting pressure on food supply chains and impacting food safety. This makes the protective potential of food irradiation even more critical. Already, several countries provide irradiated food rations during natural disasters when hygiene and cold storage are disrupted. With the Intergovernmental Panel on Climate Change expecting crop yields to become more variable due to climate change, some countries are considering using food irradiation to improve conservation of staple supplies, such as wheat, rice and maize. Food irradiation calls for shining beams of energy such as X-rays, gamma rays or electron beams onto food, because it destroys bacteria that can cause food poisoning, it neutralizes insect pests in food consignments and prevents them from hitchhiking across boundaries. It maintains food quality by destroying spoilage organisms or suppressing sprouting. It protects packaged food from microbial and insect contamination. Food irradiation is not a panacea. It will not resolve all climate-related challenges to food security, but it is playing an increasingly important role, helping to ensure that all people have access to sufficient, high-quality food to lead active and healthy lives.
Okay, I hope this lecture help students understand food irradiation technology and application if available. And at least as a consumer, they think the new technology positively and utilize more in the future. So please uh, aware of are aware of this new technology and use it as our future. Thank you very much for your attention.